Hi everyone. Today we'll be taking a walk through CelerData BYOC's data control plane. Thank you for considering CelerData as your managed StarRock solution. By the end of the brief walkthrough, you'll see how CelerData enhances infrastructure provisioning and provides a top-of-class solution for enterprise workloads. Our first pit stop will be the clusters page, where we can see all of our current clusters. Today as an example, we'll be discussing a fresh cluster I recently made called Ron's Elastic Cluster. Let's click on this cluster. Once I click on the cluster, we're greeted by a cluster overview page. We'll see things like cluster price on the CelerData side, which is dictated by CCUs or CelerData Cloud units, cluster usage month to date, and any warehouses we may be running. Furthermore, we see important cluster properties like the unique ID that's tied to our cluster, the name, the cloud provider we're running on, the region, type, and other access information. At the bottom right, we can see the data delta over the last day, and on the left we get some helpful tidbits on how to access this cluster via JDBC or MySQL client. Let's jump over to the Warehouses tab and see what's in store there. By default, BYOC comes with one warehouse. To recap, warehouses are physically isolated groups of compute nodes that allow us to serve multi-tenant cloud environments and business use cases. With some simple cluster configuration, your business analysis, dashboards, ad hoc queries, and batch workloads can all live on distinct compute resources. Creating additional warehouses is as simple as clicking Create Warehouse, and there we can define the compute node we'd like to attach. Clicking on our one default warehouse, we see a similar overview as we saw before at the cluster level, but now at the warehouse level. Notice the resource utilization indicator on the right side. This warehouse is only composed of a single compute node. But alas, warehouses don't end at basic provisioning. In fact, if we click on the Resource Scheduling tab, we can auto-scale our compute nodes per warehouse. Clicking the Edit button and toggling node scaling on, defining CPU-based thresholds is the easiest it's ever been. And you can define scale in and scale out policies on the fly. Moving over to the Deployments tab, we can see more information about our current deployment and what one compute node entails, such as availability zone, virtual CPUs, and the EBS volumes we have attached. As you scale and experiment with your BYOC cluster, you'll likely be interested in passing database parameters. We can do that at the Warehouse Parameters tab and also assign any additional AWS tags associated with your resources. Let's zoom back to the main cluster page. Trending to the right, we see the credentials and configurations that actually constitute our cloud settings. The first being the deployment credential, which is an IAM role which is responsible for actually provisioning the resources on the cloud. Infrastructure such as load balancers, EC2s, VPCs. The network configuration, which gives us information about our VPC. Of course, we can operate on public and private clouds. And lastly, the data credential, which is an instance-level permission that allows our nodes to talk to abstractions like object storage and other data services within our cloud provider. Next, we take a look at the Resource Scheduling tab, which lets us auto-suspend our cluster during times of inactivity, so we can focus on our workloads, not unnecessary costs. We can get very specific with our scheduling permissions as we can define the hours and days to keep our cluster up via scheduling policies. At the bottom, you'll also see storage auto-scaling for your coordinator nodes, configurable via steps. In the Deployments tab, similar to the Warehouse Deployments tab, we get a higher level view of our front-end nodes and compute nodes. Things such as hosts, zones, you get the idea. Same goes for the Cluster Parameters page. And based off of demand, we've also included a nifty IP access list page to restrict access straight from the main data control page. To briefly go over some additional bells and whistles, I'm here on the Access Control tab. This page tells us who has access to the BYOC control panel. We can invite members and grant them any roles we'd like. Heading over to the Roles page, we have some default roles out of the box, like Account Admin, Cluster Owner, Organization Admin, to give some basic access control features that most organizations would need. But as you can see, you're free to create your own custom ones as well. The Alarm tab allows us to set alerts and pipe them directly to emails. Some folks like integrating with their favorite observability tool, but with BYOC we can get those features out of the box. Click Create a New Policy, and you're on your way to defining endpoints, alarm thresholds, and intervals. The billing page, as expected, allows you to view billing across all clusters, but also at the account level. On the topic of accounts, CelerData BYOC supports single sign-on, so you can link with the IDP of your choice and securely log in across all your accounts. BYOC operates under the notion of having users under an organization, which serves as the parent structure linking all company accounts. The root account, created during sign-up, acts as the administrator with full privileges and handles billing for all accounts in the organization. Each account can independently manage its own clusters, data, and users for workload isolation, allowing large companies and enterprises to assign separate accounts to departments while maintaining centralized billing and governance. So once you're in one of these accounts, how do you actually go about creating a cluster? Well, we can navigate back over to our main clusters page and click Create Cluster on the top right. Here, we'll be prompted to either create an Elastic cluster or a Classic cluster on our cloud provider of choice. We'll opt for Elastic in this case as we want true separation of storage and compute, and we'll select AWS. On our page now we see a multitude of options. First, what our cluster name is. Do we want to go multi-AZ with this deployment? Or how about toggling coordinator high availability mode? We recommend at least 3 coordinator nodes and 3 compute nodes to ensure high availability, so this would probably be a good option. As a drop-down, we can select the size of our coordinator nodes with a wide variety of support. We can also toggle our EC2 architecture. Maybe we're going for an x86-based machine, or maybe an ARM-based architecture, which would be AWS Graviton support. Our next important step is to select the size of our compute nodes. CelerData extensively supports general-purpose and memory-optimized EC2 machines here as well. Lastly, we're free to add any relevant tags from our cloud provider here. If we're satisfied, we can jump over for a manual deployment or go for CloudFormation for a simpler setup. Once you've set up your accounts, you can take a look at the full account activity on the control plane through the audit log, which tracks useful metrics such as user logins and logouts and cluster level activity. And that's the data control plane. If you're interested in learning more about BYOC, visit CelerData.com for more info or speak to one of our data professionals to set up some time on the calendar. Thank you.